Okay, students, this is a video about the trigonometric equations. We talked about this lesson 5.5, a lot of applications of what we've been talking about. You may notice over here a lot of the goals of our work with trig could be used in these types of problems involving trig equations. So let's go right to it and let's go over some of these problems we did in class. Let's start with number one. Find all solutions. That's the key to this problem. Find all solutions. So that means all the domain values that work in this equation. All right, well, here's the equation. 3 sine of x minus 2 is equal to 5 sine x minus 1, right? We could just subtract that. That's like 5x minus 3x. 2 sine x minus 1 is equal to negative 2. All right, so let's add 1. We'll put the 1 over here. That's negative 1 is equal to 2 sine x. Of course, if we divide that by 2, then we have sine x is equal to negative 1/2. Okay, now where is sine negative 1/2? Using your unit circle, you have quadrant 3, which is 210 degrees, and you have quadrant 4, which is 330 degrees. But the question is all solutions. So it would be 210 degrees plus 360n, okay, right? Because that takes into account all of the possible angles, and 330 degrees plus 360n. So this is the answer we're looking for if I say solve for all angle values. Hope that helps. All right, question number 2. Now we have a trig equation involving what's called multiple angles. So here's what's different is this 3x over here. No problem. Just copy the problem down. Tangent of 3x is equal to 1. Now we could guess and say 45 degrees, and then just say must be 15 degrees. Now we need a method here to solve this. So here's what I would do. I would just substitute the 3x, take that out and put a in its place. So tangent of a, let me write that. Tangent of a is equal to 1. Now where is tangent 1? Is tangent at 45 degrees, which is pi over 4, and it is also 1 at 5 pi over 4. But now wait a minute, the tangent function has got a period of pi. Okay, so actually we don't need this value because that's taken into account with the pi period. Now the question is, we solved that for a, but we don't have a, we have 3x. So rework the problem or rewrite the problem in this way. Let's divide everybody by 3. Remember, divide a fraction, multiply the bottom. All right. Now remember, that's the same thing as pi over 12 plus 4 pi over 12, and it's easier to work it that way. Now we want all of the values, here's the key, all of the values beginning with 0, ending at 2 pi. So we do n equals 0. If I plug in n equals 0, I get pi over 12. That's one answer. N is equal to 1. If n is equal to 1, I have pi over 12 plus 4 pi over 12, which is 5 pi over 12. That's another answer. And if I put n is equal to 2, I'm going to have another 4 pi, which is 9 pi over 12. I keep on adding 4 pi each time. Okay? Hopefully this problem makes better sense now, okay? 21 pi over 12. Now, the next one's going to be 25 pi over 12, but that will not work because that's over our 2 pi limit in our domain. So These are the answers we're looking for the solution to example number 2. I hope that helps. All right, let's look at example 3. Same type of problem, okay? Same type of problem. Here I have a sine of x over 2 is equal to radical 3 over 2. Again, let's change that. We'll call that a. So sine of a is equal to radical 3 over 2. Now, where is sine radical 3 over 2? It's not 30, it's 60. It's not 30, it's 60 here and here. So that's going to be pi over 3, and it's going to be 2 pi over 3. Okay? Now remember, that was a. Okay? Remember, pi over 3 plus 2 pi n. That's periodic nature of sine function. All right, now what we're going to have to do is we're going to have to take each of these equations and solve for x. And the easiest way to do this is just multiply both sides by 2. All right, let's put that over here. So that's going to be x is equal to 2/3 pi plus 4 pi n. Okay? And of course, this one we're going to do the same way. And this is x is equal to 2 pi over 3 plus 4 pi n. Now, let's start with n is equal to 0. If n is equal to 0, the top equation is going to just give us 2/3 pi, right? Because that's 0, and then that would just knock that out. The other one would give us 2. Did I not write that right? Multiply by 2, that should be a 4. Okay, I'm sorry. So the other one would be 4 pi over 3. Okay, for the second equation. Now, if n is 1, notice I'm going to have 2/3 pi plus 4 pi. Now look, we can only go up to, according to our directions, we can only go up to 2 pi. So we are going to stop right there where n is equal to 0, and these are my two answers. Okay? I hope that helps. Let's take a look at this next question. Solve an equation in quadratic form. Well, I'm just going to play make-believe for a second. Okay? If that was a quadratic and it was set equal to 0, I could easily factor that into 2x and x. And, right, we did this like a million times. And I'm going to say -1 and +1, right? Figure that out. That does work. All right, but I don't have x. My x term in my problem is actually just cosine x. So it's really going to be 2 cosine x minus 1. This is my x, okay? And then this is going to be cosine x plus 1. All right, now let's solve these for 0. Just like we do the quadratic, let's solve these. This would be cosine x is equal to, now what we got to do, we got to move the 1 to the other side and divide by 2. Again, so in this problem right here, we're going to set it equal to 0, and cosine x has to equal -1. Also notice our directions say between 0 and 2 pi, or between 0 and 2 pi. Okay, those are the domain values. Well, we know that cosine is -1 at pi. And we also know that cosine is 1/2 at 60, which is pi over 3. And going around in quadrant 4, 5 pi over 3. Okay? All right, everybody knows your unit circle. Don't forget your green sheet. It'll help you out. All right, so that's problem 4. I certainly hope that helps. All right, number next. Now, this problem is a lot similar to the last, okay? Again, we're just working problems here. we want to solve that for sine. All right, so we're going to add the 1. Then we're going to divide by 4. Okay, and we're going to take the square root, right? Square root of both sides, okay? So here I have sine of x is equal to plus or minus 1/2, okay? What that means is we need to find all the values where sine is 1/2, and then we need to find all the values where sine is negative 1/2 in our range of values. Well, we know we've been through this before. It's 1/2 here and here, and negative 1/2 here and here. Those locations are pi of a 6, 5 pi of a 6. The negative ones are 7 pi over 6 and 11 pi over 6. So these set of values are all the answers to that problem. I hope that helped you. All right. Now we got a new problem here, and it's very, very interesting. And the question is, solve this problem. Well, okay. So the reason why I write it down is when I write it down, it makes it my problem. Okay, hopefully that makes sense. Remember, was trying to solve for the same domain values, the same domain values. Now, how about just bringing the tangent to the left? Now, what advantage does that do for us? Well, that's a good question, okay? We're trying to solve the problem. Whoops. Okay, now I got something set equal to 0. If I could just factor something out of here, I could factor a tan x out of here. That would be sine squared x minus 3. Okay? Now let me set both of these equal to 0, right? Because that's what we do with quadratics. Okay? All right, this guy is tangent is 0. Remember, it's 0 at 0 radians and at the pi. Okay? So we got that. Now, we're going to have to solve this. Sine squared x is equal to 3. Take the square root, square root. Sine of x is equal to the square root of 3 plus a minus. Square root of 3 is about 1.73. Now remember, sine only goes from 1 to negative 1, so this makes no sense. We could disregard that. We already have these two answers over here, and there you go. That's the way to do that problem. Okay, well, here's a new problem. Now, notice here I have a cosine squared, and I have a sine. Well, I don't know how to substitute sine and cosine, but a cosine squared, I know that sine squared plus cosine squared is equal to 1, Pythagorean identity. So cosine squared is equal to 1 minus sine squared. Okay, so what I'm going to do is I'm going to rewrite this 2 times 1 minus sine squared plus 3 sine of x is equal to 0. Now this is going to be 2 minus 2 sine squared x plus 3 sine x is equal to 0. Hey, I could rearrange these terms, okay? Now I don't like to have a negative in front, so I'm going to distribute a negative sign through the whole problem. Okay, now it's a factoring problem. I think I can factor this. Okay, I think I can. I know I can. Okay, this is 2 sine x. This is sine x. Okay, now I need a 3. I can get a 3 if I have a 4 and a 1. I need a negative 3, so that's got to be minus and that has to be plus. Okay, let's look at this. If I set that equal to 0, sine x is 2. Well, that won't work. Okay, and then sine x is negative 1/2, which we know are these two answers right there. So I hope that helped you with that. We'll do part 2 video for the other problems.